Hello and welcome to the lesson on polarization. So today's goal, I want you to be able to explain the concept of polarization, and then I want you to be able to apply it to real-world applications, including appropriate calculations. We're going to have an opportunity. I've got some Polaroids, and we're going to do a couple of neat little activities where you get to actually try them and see them firsthand to see what they actually do. But here's the theory behind it. So we already talked about it. You've seen this diagram again before, and now you got to draw it again. But thanks to Maxwell, we know that we have light traveling as an electromagnetic wave. And it's a transverse wave, which means that it's vibrating perpendicular to the direction of travel. And there's our diagram for that, and that's what we've already talked about. So if we move on to kind of the next phase then in our journey through light here, light's not a single wave, okay? A light source produces a huge number of transverse waves, and they're vibrating perpendicular to the direction of travel, but they don't necessarily all travel in phase. So what I'm trying to say is that you are going to have waves, and for this kind of diagram, we're just going to look at the electric field of the electromagnetic wave. So we're just going to look at the green wave itself. So what I've got here is these dashed lines indicate different axes. So for example, I'm going to have one wave, and this, we'll see how this goes. We're going to have one wave that is vibrating in that plane. All right, so I might change colors here just to help with a visual aid. All right. Then we might have one that's vibrating on the y prime plane. So we're just looking at the electric wave. So they're oscillating. They're not always straight up and down or like they would be on a piece of paper. They may be off the plane as well. Whoops, that's not a very good attempt. So this wave is on this plane, parallel to the y prime plane. And then you could, of course, have a third wave oscillating on this plane here. So, yeah, now you're all laughing, saying, how's he going to draw this? Well, the joke's on you, because I'm just going to make an attempt to draw it this way. So the whole point here is that waves are not necessarily all coming out in the same manner. They're all rotated around a particular axis. So if we're looking down the end of it, all right, so if we are looking end view, all right, my green wave is up and down, so there's the crests and troughs. My blue wave is kind of on this plane, so there's a crest and a trough. And my red wave is on this one, there's a crest and a trough. So they're all rotating in different planes, all right? And there could be an infinite number of them emanating from that source. So we got waves that are vibrating out of plane, all right? So if that's not clear enough, we can talk about it in class, or I can get out some cardboard and string and we can talk about it and give you kind of a 3D model. So a couple of definitions here as we move through. First one is unpolarized light. So that's waves that vibrate in all directions. So this is really an example in this previous slide here. This is an example of unpolarized light. All right, unpolarized light. The white light waves are vibrating in all planes perpendicular to their direction of travel. Polarized light is a wave that vibrates in only one direction. All right, so one direction means that it is in a single plane, still perpendicular to the direction of travel. So how do we create polarized light? Well, there's things that are called Polaroids, and what they are simply films that have very, very thin slits in them. And what they do is they allow light vibrating in a specific direction to pass through them. So for my drawing here, on the left side here, we are going to draw kind of that crazy diagram that I had on the previous page. So I'm going to have my blue wave going up and down. So let's put it on the vertical. Just like that. And I'm going to stop it at the Polaroid. Now I'm going to try drawing a couple other waves. So let's do the green wave. And let's put it on this kind of slant here. And again, we're only looking at one type. I'm not drawing the magnetic and the electric field. I'm just drawing the electric field. And then let's put a red wave in here. And this red wave we'll put it on this kind of angle. So again, if we look at an end view, just to help you visualize what's going on, we have this unpolarized light approaching our Polaroid. So the green one is the one that's straight up and down. Okay, and what I've tried to do is I've tried to draw blue on that angle and red on that angle. So the light comes to this Polaroid, and when I mean obviously exaggerated the slits here, but these very small slits that are in the Polaroid, what they're going to do is they're only going to permit certain light to pass through them. All right, so if the slit is vertical, that means that any wave that is vertical will pass through. And I think I messed it up. I think I had blue going straight up and down and green on the angle. Won't matter for the guys. You only have one pencil anyway, so it's not like you have multicolors. Sorry for the girls, because typically you're the ones that are prepared. So that means that vertical, if the slit is oriented vertically, only waves that are vertical will be able to pass through. All right, so my blue wave can pass through the slit because it's oriented in the same direction. All right, so what we have in this region then is a decrease in intensity of light. So decrease in intensity. And that's because not all light's getting through. Not all light passes through. So the Polaroid is blocking certain light from passing in it, and it's the ones that are vibrating out of phase. Now, if I have a second Polaroid that's now perpendicular to the first Polaroid, that would mean that my blue wave would end up stopping at this point here. It would be blocked from passing through. So in this region here, we would have no light. And I don't know what I was going to spell lightning, I guess. No light. All right. So if you have two Polaroids that are perpendicular, okay, light will not pass through. So Polaroids at 90 degrees block all light. So hopefully now you're asking yourself, well, what happens if they're not at 90 degrees? What happens then? And that's an excellent question. What we get into is kind of talking about the orientation between the two slits. So these are Polaroid circles. The black lines represent our slits. Okay, so just label this. So those are our slits, and this is our Polaroid. Okay, so what we can do is we think of it as like a picket fence. That was kind of the easiest way it was explained to myself when I was in your situation learning and going through this process. So before you draw anything, watch or listen to what I'm going to do, and then you can figure out how you're going to sketch it for yourself to remember, because I'm going to erase stuff as I go here. So I have my two Polaroids that I can move around. So I'm going to align them kind of the way they are on your page here, and I'm going to have them oriented in the same direction. So if I have a blue wave coming through here, it will pass through both Polaroids. All right, and the reason for that is because if I overlay the two Polaroids, okay, the slits line up, they're the exact same. What happens if the slits are perpendicular? Well, we just talked about that. So if I make it perpendicular and we line them up, we see that the slits cross over such there are holes, and just a series of dots is where they would line up. And what that does is it blocks light from passing through. The light cannot pass through two Polaroids that are set perpendicular to each other. So what happens if they're oriented at an angle? So if I can grab that top one, and when we look at it in terms of an angle, what happens is that some light will be able to pass through. So the closer we approach 90 degrees, the less light will be able to pass through. So as Polaroids are oriented closer to 90 degrees, less light can pass through. So why is that? Well, the best I'm going to be able to explain it to you, if I can grab one, is that if it's just off a little bit aligned, these regions are actually significantly large. So if I was to magnify that, the overlap, oops, try that again, the overlap is such that this is actually big enough right here for some light to pass through, for some light waves to pass through. As you twist that line further and further apart, that cross section becomes smaller and smaller. So the window decreases in size. So less light is able to pass through as that window of opportunity decreases. All right? So Polaroid.